Okay, so we're going to talk about naming compounds that have transition metals in them. So let's first look at what a transition metal is. If we've got our periodic table here, your transition metals are all of these in the orange here. Okay, so these are the metals that we're going to be focusing on. A couple of things just to make sure that we're clear on. Almost all of these make more than one charge. So if you're looking at this column right here, all of those make a +1 charge. It's the only charge that they make. Everything in this column makes a +2 charge. It's the only charge that they make. These right here in the middle have the potential to make more than one charge. All right. So there's only two that we are going to work with that make only one charge, and that is silver and zinc. Okay. So silver only makes a +1 charge. All right. So there's always not a number sign. Always +1. Okay. The next one is zinc. Zinc always makes a +2. All right, so those are the only two that we're going to be dealing with in the transition metals that make just one charge. One other thing that we need to add is that there are three outside of the outside of the transition metals that we're going to work with that make more than one charge. So they're going to be treated like transition metals, and that's tin, lead, and bismuth. Okay, tin, lead, and bismuth make multiple charges, so you have to treat them like transition metals. So lead, tin, and bismuth treated like transition metals. Okay, so that's what we need to get out of the way, and that's what we need to make sure that we understand going in. Okay, so if we go back to just the notes, if we're going from the name to the formula, okay, name to formula, the example we're going to work with is lead 2 chloride. Okay, now you may be wondering why we have these Roman numerals here. All right, Roman numerals are there so we identify the charge. Okay, they're there to identify charge. Spell it right. Of the metal. Okay, because lead can make more than one charge, we have to identify which one we're using. Okay, so step number one. All of this is very similar to what you've already been doing. So step number one is to write the symbol in the charge. Of the metal. Okay, and the good thing about transition metals is you don't have to look at the periodic table to determine what the charge is. It's given to you right there in the name, lead 2 chloride. So lead is Pb, and 2 tells you that it's a 2+ charge. Okay, and then you're going to write the charge for the nonmetal. So chloride is chlorine, so Cl. You look back at your periodic table, and chlorine is in the 7th group, and it always makes a -1 charge. Okay, so step number 2, you're going to cross the charges. Just like we've been doing. Okay, so I'm going to take these charges, and I'm going to make them the subscripts. All right, so the 2 from lead becomes the subscript for chlorine, and the -1 from chlorine becomes the subscript for lead. So we don't need the positive or the negative. We're just interested in the numbers, and you don't have to write a 1. So your answer becomes PbCl2. And there's your answer. So let's do a couple more examples. Iron 3 oxide. And before we go any further, let's make sure that we're clear on what the Roman numerals are. Okay, so 1 through 6 is really all you're going to need to know. I, 2 I's, 3 I's, an I and a V is 4, a V is 5, and a VI is 6. If you were not already aware of that, you've got them written down now. So iron 3 oxide, iron is Fe. The 3 tells us, the Roman numeral 3 tells us that it's a 3 plus charge. Oxide, we're going to look at oxygen. It's in the 6th column, so it's going to create a -2 charge. We're going to cross those charges. So the 3 from iron becomes the subscript for oxygen, and the 2 from oxygen becomes the subscript for iron. And you get Fe2O3. Let's do another one. 2 more. Mercury 2 sulfide. Okay, so mercury, you look on the periodic table and it's Hg. The Roman numeral 2 tells you that it's a 2 plus. But then you look on the periodic table, sulfur is right underneath oxygen, so it also creates a 2 minus charge, just like oxygen does. We take these charges and cross them. Again, we're only concerned with the numbers. And you have Hg2S2. However, it needs to be simplified. So anytime you have numbers that are the same, you're going to simplify those, and it just becomes HGS. So you have to simplify that. Pretty much the only instances where you're going to be simplifying is where you have like a 2 and a 2, and X and Y are just placeholders for your elements. Maybe a 3 and a 3, or in a case where you have a 2 and a 4, you can actually simplify that down to a 1 and a 2. So those are going to be your 3 main instances where you're going to need to simplify. Last example of this, use a polyatomic ion in here. So we've got chromium 2 nitrate. Okay, so you're going to look at chromium. Chromium is Cr. The 2 Roman numeral tells you it's a 2 plus charge. And then you're going to look on your list of polyatomic ions and see that nitrate is NO3 with a -1 charge. It's not just NO3, it's the negative comes with it. So nothing changes. You're still going to take your charges. Okay, and then we have to keep nitrate together. So in order to keep nitrate together, we're going to put parentheses around it. So you have Cr, and the 1 comes down here, so there's no subscript needed there. And then you have NO3. Well, we have to have a 2 on the outside of NO3. So you're not going to write it like that, because that looks like NO32. It looks like you have 1 nitrogen and 32 oxygens. Okay, so you're going to put parentheses around the nitrate, around the polyatomic ion. And what that tells us is that now we have 2, this is not exactly how it looks, but it's good enough. We have 2 nitrate polyatomic ions there. Okay, so what it ends up doing is it tells you you have 6 total oxygens and 2 total nitrogens. So that's how you deal with a polyatomic ion. So let's go from formula to name now. Formula to name. Right quick. The example we're going to use is PbCl4. All right, now, the way you do this is basically we're going to reverse the crossing mechanism. So we're going to take the subscripts right there and uncross it and make the charge for the metal. Okay, we know lead has more than one charge, so we're going to need to find out which charge that is. Everything else is the same. You're going to name the metal, lead. Okay, then you're going to identify the charge through the uncrossing process of the subscript. So because that's a 4, we're going to put a Roman numeral 4. And then Cl is chlorine, and you're going to add IDE to the end of the root. So it becomes chloride, just like it always has. You're not going to name these any differently than you would a binary ionic compound. The only difference is now you have to have a Roman numeral to identify the charge on the transition metal. Another example is CrNO3. Now, when you have a polyatomic ion, you have to be able to identify a polyatomic ion. So what I would recommend is to always put parentheses around your polyatomic ion. Okay, and that's going to help you keep it together, because what a lot of people want to do, take away those, what a lot of people want to do is go, okay, we have chromium, and now we're going to want to uncross that 3 and make it chromium 3. Well, that's not how you do it, because you can't take the 3 away from nitrate, because the 3 is part of what nitrate is. So putting the parentheses around them keeps that together in your mind and visually. So what you end up seeing is that there's nothing out here. Okay, and when there's nothing out here, it's usually a 1. So you're going to uncross that 1, chromium 1, and then you're going to name nitrate. So chromium 1 nitrate. Let's do another one with polyatomic ion. Okay, now this one's pretty easy because it already has the parentheses around it, and it already has a number on the outside of those parentheses. You don't have to have parentheses around every polyatomic ion. I just find that it's easier when you put them around there. So we're going to uncross these charges. Okay, and we're going to say that Cu is copper. We're going to take this charge right here, or sorry, this subscript, and make the charge. So now it's a 2. Okay, because what you end up with here, if you break them apart, is Cu2 plus, and then your phosphate polyatomic ion. So it's copper 2, and then you're just going to write the name of the polyatomic ion as phosphate. You don't have to put a Roman numeral out here for phosphate because it's always a 3 charge. Okay. Let's do one more example. We have HGO. Okay. Now, here's where it gets hard. You know that oxygen creates a -2 charge based on where it is on the periodic table. However, there's nothing down here. Okay. And if there's nothing down there, then you know that this has to always also be the same because they've simplified. Okay? So if there's nothing down there and you know that oxygen, there should be a 2 here. There should be a 2 right there because the 2 should come from there. Okay? But that's not the case. So why would that be? That's because, like we just said, we've simplified this. So if we've simplified it and we know a 2 has to be there, then what has to go right here? Well, that has to be a 2 as well. So when we write it, these two cancel each other out, and it's just HGO. Okay? So what are we going to do with that 2 that we know has to be there now? We're going to uncross that. Okay? And we're going to make it mercury 2 oxide. Because basically what we've done here is we've broken this apart into Hg2 plus and O2 minus. Okay, so when you cross those and make your formula, you're going to cancel those out. Had you mistakenly made this a 1, okay, had you made that a 1, if you look at it from this perspective here, and then you go forward and actually cross the charges like you normally would, you would get Hg2O, which does not match, our original HGO example. Okay, so a little bit of checking in the end can help you out there. That's the hardest part. This is the hardest part right here of transition metals, is knowing when something has been simplified and when it hasn't been simplified. Okay, that is naming ionic compounds with transition metals.